Consider a crowd of stationary seated people. Can a Wi-Fi link nearby count the number of people in this crowd? This is a very challenging problem due to the lack of measured body motion. We observe that while people are stationary, they engage in small in-place body movements called fidgets. We propose that the aggregate fidgeting of a crowd, which can be extracted from Wi-Fi measurements, carries information on the total number of people. As an example for this crowd, we can see their individual fidget sequences as a function of time on the right. We can also see the aggregate fidget process that results from the superposition of the individual fidget sequences. We define a crowd fidgeting period as a time period where at least one person is fidgeting, and the crowd silent period as a time period where no one is fidgeting. This aggregate fidget process is what the Wi-Fi link will measure. But how can we extract the number of people from these crowd fidgeting and silent periods? Our key observation is that this problem resembles an old queuing theory problem. Consider an MG infinity queue. The busy and idle periods of this queue resemble our crowd fidgeting and silent periods. By borrowing tools from queuing theory, we then estimate the total number of people from the crowd fidgeting and silent periods. We extensively tested our approach with 47 experiments where up to 10 people are engaged in different activities. For instance, in this patio area, we ran 19 experiments where up to and including 10 people sat down in rows of chairs together to watch a movie while a Wi-Fi link collected Wi-Fi measurements. In different experiments, people sat in several different seating configurations, some of which are shown in the figure here. This table shows the final estimate for the crowd count for all experiments, as well as the true number of people. We can see that the estimation error is 0 or only one person in all experiments except only one, which shows a very good counting performance. In this indoor apartment, we ran 4 experiments where 4 people sat together in different seating configurations to watch a lecture. We can see that the counting error is 0 or only one person in all experiments in this indoor area. In this covered area on the right, we ran 4 experiments where 8 or 10 people sat in different seating configurations while engaged in a reading activity. We can see that the counting error is 0 or only one person in all experiments in this area as well. Finally, in this location, we placed the Wi-Fi link behind the wall to show that our method can still detect the crowd fidgeting data and consequently count the number of people even through walls. We ran 20 experiments where up to and including 10 people seated in different configurations were engaged in either reading or watching a documentary. In this setting, we get a counting error of 0 or only one person in 18 out of the 20 experiments, showing a very good counting performance even in through-wall scenarios. See the paper for more details and results.